Hi there and welcome to another A-level maths video from HEGARTYMATHS. In this video we're talking about integration and we're doing integration using partial fractions. So by the end of the video I'd like us to be able to integrate algebraic fractions, functions that look like algebraic fractions using the technique of partial fractions. Okay, firstly, two standard results we need to be familiar with. If we integrate the reciprocal function 1 over x with respect to x, we get the natural logarithm of x plus a constant. Now I write a modulus sign around this because the natural logarithm only applies for when x is positive, so I put a modulus sign to make sure x is positive. And a corollary or an extension of this is if I integrate 1 over a linear function of x, like ax plus b, with respect to x, for example, let's say for example I'm integrating 1 over 3x add 2 with respect to x, the integral of that would be 1 over a, the natural logarithm of the modulus of ax plus b plus constant c. So in the case I've just highlighted here, it would be 1/3 the natural logarithm of the modulus of 3x add 2 plus our constant of integration. Okay, so these two here, this result and this result, are important in this video. When you notice a function with 1 over a linear factor, it's a logarithmic answer as your integral. Okay, so that's something we need to bear in mind in this video. The other thing are our partial fractions results. Now I've done a whole set of videos on all the rules for partial fractions in the core 4 on HEGARTYMATHS, so make sure you check those out. But a quick summary of these are as follows. If I have a linear which is x to the power of 1 over a quadratic x to the power of 2 with two distinct factors, I get a number over the first factor plus a number over the second factor. That's how I'd write it in partial fractions. If I had a quadratic on top, a power 2, and a quadratic on bottom, I would then get myself a linear term, a number or a constant, and I would get a number over the first factor and a number over the second factor. So the difference between these two is that the order of the numerator and denominator are the same, hence I get a linear factor here, not a linear factor, a constant number there. If the numerator was actually bigger than the denominator, here it's order 3 and the denominator is order 2, I would then get a linear term in terms of x plus a number over the first factor and a number over the second factor. The next type of one I could get, let's keep going with this. I could get say I've got a linear over a cubic, so that's order 1, order 3, okay? But two of the factors are repeated. I end up getting a number over the first factor, a number over the second factor, and a number over the second factor all squared. And they are the main results I need to know as part of this, but I'm not explaining those results here. You need to look in the partial fractions videos for where those results come from and why they work, but they're the results we're going to be using in this video. Okay, so let's do this by way of an example. We're trying to integrate the following. Now, before you even go on integrating, think to yourself, is this a standard integral? And the answer is no. It is an algebraic fraction. Okay, and the first thing to think of, could you write this in terms of partial fractions? Because if you could, and it would be a number over the first one and a number over the second, they'd be things you could integrate. So as working, we're going to write this in partial fractions. So this is not integrating, this is working. So we have x subtract 5 over x add 1, x subtract 2. Okay, and I'm going to, the partial fraction form of that is linear on top, quadratic on bottom, so I get a number over the first factor plus another number over the second factor, like that. And my next line, okay, making x plus 1 x subtract 2 the common denominator here, I could write that x subtract 5 must be a x subtract 2 plus b x add 1. Okay, and now what you could do is you could let x, if you let x equal 2 here, I would get negative 3 is going to be equal to 3b, so therefore that tells me b is negative 1. And if I let x equal negative 1 to get rid of this, then I would have that negative 6 is identical to negative 3a, so therefore a is equal to 2. So I could rewrite this thing here, this integral. So instead of trying to work out the integral of x subtract 5 over x add 1, x take away 2 with respect to x, I could say this is actually the same as a over x add 1, so the integral of 2 over x add 1 with respect to x, and then take away the integral of 1 over x take away 2 with respect to x. And in fact, in one move, I hope you don't mind, I could take that factor of 2 out like that and write it like that. Now these are things I can integrate. This integrates to 2, the natural logarithm of x plus 1, and this integrates to subtract the natural logarithm of x take away 2, and then you have plus constant. Now you could use your laws of logs if you wanted to. If you wanted to combine these, you could write that as ln x add 1 squared take away ln x take away 2 plus c, and then you could combine them. You could write that as a natural logarithm of x add 1 squared over x take away 2, all of that modulus, plus c if you wanted to do that. Okay, and then we'd be done in that regard. Now, there's actually one other thing you could do that's maybe useful for you to think about. It'll be useful later. Because that's a plus c, there's absolutely no harm in the world in writing that as a logarithm of some number, like let's say the logarithm of a. Like c can be written as a logarithm of some other number a. So this whole thing could be written as the natural logarithm of x add 1 squared over x take away 2, like that, plus logarithm of a. And then we can use the logarithm rule. We could say we could then multiply the logarithm to say that's the natural logarithm of a x add 1 squared over x take away 2, like that. Now this is not essential in this part of the video, but I'm going to do this for each section just because when we're using these later, when we're going to be solving differential equations, this could be very useful for us to write our constant in terms of a logarithm and then to combine everything in terms of one logarithm. That can be very, very useful indeed. Anyway, I'm done at that point. Okay, so the next one. This is an algebraic fraction, and what I should spot as some working that this is a difference of 2 squares. So this 2 over 1 subtract x squared is actually 2 over 1 subtract x, 1 add x, a difference of 2 squares. And I could certainly write this in the form a over 1 subtract x plus b over 1 add x in partial fraction form. So my next line would therefore be that 2 is the same thing as a 1 plus x plus b 1 subtract x. And if I let x be 1, then I would get that 2 is identical to 2a, so a must be equal to 1. And if I let x be, let's say, negative 1, then 2 must be identical to 2b, so therefore b is also equal to 1. So I could rewrite the integral up here. I could rewrite the integral of 2 over 1 subtract x squared with respect to x as the integral of 1 over 1 subtract x with respect to x plus the integral of 1 over 1 add x with respect to x. And this thing here, well, what does that integrate to? Well, it would integrate to ln of 1 subtract x. Now, if I differentiated this, I would have got negative 1 over 1 subtract x. But I want positive, so I must divide by the negative 1 here, make that negative, plus the natural logarithm of 1 plus x, plus constant. Okay, and that's fine like that. Now, if I wanted to combine it, I could write that as negative ln 1 subtract x plus ln of 1 plus x plus ln of some number there. So I've got two ln's added, they could be multiplied, and then a subtract, so I can divide by that. So I could write that in one combined ln as ln of a 1 plus x divided by 1 subtract x, like that. And that would be the combined version of that in perfect form. Okay, next one. I know the top is a factor, or is a quadratic, and the bottom is a cubic. So I could write 8x squared subtract 19x add 1 all over 2x add 1 x subtract 2 squared in this form. I know it's going to be a over the first factor, 2x add 1, plus b over the second factor, which is x take away 2, plus c over the second factor, which is x take away 2, all squared. So my next combined line, I would write that not 18, but 8. I could make this have a common denominator, and I would say that 8x squared subtract 19x add 1 is therefore equal to a x take away 2 squared plus b x take away 2, 2x add 1 plus c 2x add 1, like that. And then what I could do is I could use various values of x to find what a, b and c must be. Okay, now the first thing I'm going to do is, if I was doing this, I would firstly write in on my calculator 8, I would write 8x squared subtract 19x plus 1. So when I do my various substitutions, it's easier for me. So I'd write that like that. And the first thing I'd substitute is x is 2. Okay, so I'm going to substitute x is 2. So calculate when x is 2, and I see I get negative 5. So here I'd have negative 5. If I'm letting x equal 2, I get negative 5 is equal to, that would disappear, and this here would end up being 5c, and this tells me that c must be negative 1. Okay, what else could I put in? Well, I could put in x is negative a half. Why? Because that would disappear and that would disappear. So if I press calculate and I put negative 1/2 like that, I get 25 over 2. So I get 25 over 2 here would be equal to, when I put a half in there, if I put a half in there, a negative half, even negative a half, so I'd have negative half take away 2, I get negative 2.5, and if I square that, so 2.5 squared, I get myself 25 over 4. So this would be 25 over 4a. Divide both sides by 25, I'd get a half is identical to a quarter a, and therefore I get myself that a must be equal to 2. Times in both sides by 4. So a is equal to 2 in this case. Okay, and then, so I've got myself a is 2, all I need to find is b now. So I would let x be equal to 0, for example. This whole thing would be equal to 1. Okay, so what I would have here is what a was 2, and I would have 0 subtract 2, which is negative 2 squared, so I'd have negative 2 squared like that, plus b, which we don't know. Putting in 0 here, that would be negative 2 multiplied by 1, and putting in 0 here, it would be whatever c is multiplied by 1, so plus negative 1 multiplied by 1. So therefore negative 2 all squared is 4, so this would be 2 times 4, which is 8. Subtract 2b, subtract 1, so we'd have 1 is equal to 7, subtract 2b. And so I'd take away 7 off both sides, so negative 6 would equal negative 2b, and therefore dividing by negative 2, b would equal 3. So that's all my partial fractions work. So I can rewrite this thing now, this integral, I can rewrite it as a over the first thing, so I could rewrite it as the integral of 2 over 2x add 1 with respect to x, plus I could rewrite it as b over x subtract 1, so b was 3, so plus 3 over x, subtract 2, the integral of with respect to x, plus, and the last one was negative 1, so I could actually rewrite that as negative, and then it was 1 over x subtract 2 all squared with respect to x. Okay, so if I call this thing the integral I'm trying to work out capital I could then just go down here and start my working off and call that capital I. So I could say I is equal to, so I should be able to integrate it. I'm going to take the 2 out of the front, and I'm going to say that's 1 over 2x add 1 with respect to x, plus 3 over 1 over x subtract 2 with respect to x, subtract the integral of x take away 2 to the power of negative 2 with respect to x. Now you should recognise that as an integral, you know it's a logarithmic one, so the answer would be 2, and this would be the natural logarithm of 2x add 1, but I have to divide by that 2, so 2 over 2, plus 3, the natural logarithm of x take away 2. And then this one here is not a logarithmic one because it's to the power of negative 2. I add 1 to the power and divide, so it would be subtract x take away 1 to the negative 1, and I divide by that negative 1, so it would be it would end up being a plus there, and I'd have plus constant. Okay, and now I could combine these. That would be just 1, so it would be the natural logarithm of 2x add 1 plus 3 natural logarithm of x take away 2 plus 1 over x take away 2 plus constant, like that. Okay, and at that point I could leave the logs like that, or I could combine them. If I really wanted to, I could combine these, bring up the power of 3 like that, just so I can combine the logs, but it's not essential, and I could rewrite that as a natural logarithm of 2x add 1 multiplied by x take away 2 cubed plus 1 over x take away 2 plus constant. Okay, so I could rewrite it like that, but leaving it at that line there is absolutely fine. There's no need to do any more than that. Okay, so I've done that example as well. Last example, is it the last example? No, there's 2 more examples I'm going to do. Now this one, when I'm writing 9x squared subtract 3x plus 2 over 9x squared take away 4, I should realise that the bottom's a difference of 2 squares, so it could be written as 9x squared subtract 3x plus 2 all divided by 3x add 2 multiplied by 3x subtract 2. Okay, and I should also realise that the top is a quadratic, power 2, the bottom is a quadratic. So when writing this in partial fractions, they've got the same order, so I'm going to get a constant term plus b over 3x add 2 plus c over 3x subtract 2, like that. So therefore my next line of working, if I made this have a common denominator, I could write that 9x squared subtract 3x add 2 would be the same thing as a 3x add 2 3x subtract 2 plus b 3x subtract 2 plus c 3x add 2, like that. Now I could go ahead and find my A, B and my C easily now. I know that the only thing, just thinking about what gives me an x squared on this side, that multiplied by that, which would be 9ax squared, is the only thing that gives me an x squared. So it tells me, because I've got a 9x squared here, A has to be 1. So A has to be 1, and if you let x be 2/3, and if you let x be negative 2/3, you can find your B and your C. And it turns out, I'm not going to go through this in this particular video here, but it actually turns out that you get the following answer. So A is equal to 1 in this case, and then you would get the following. You would get that you would get that B in our case would be equal to negative 2, and you would get C in our case, which would be equal to 1. Okay, so you could rewrite this integral that you've asked to integrate, so I'm going to call that integral I. You could rewrite this integral as the integral of A was 1, so 1, subtract 2 over 3x add 2, plus 1 over 3x subtract 2 with respect to x. So writing it in partial fractions, you would get that there. Okay, and then you could break this up, so the integral could be written as the integral of 1 with respect to x, subtract 2, the integral of 1 over 3x add 2 with respect to x, add the integral of 1 over 3x subtract 2 with respect to x. And each of these I could integrate. So this would be x, you'd simply get this here, you get the subtract 2, you know it's a logarithm of 3x add 2, but I have to divide by this 3, so it would be like that, plus the logarithm of 3x subtract 2, and again you'd have to divide by that 3, plus your constant. So I could combine these to x subtract 2/3 natural logarithm of 3x add 2, plus 1/3 natural logarithm of 3x take away 2 plus constant. Now I could combine these logs, but there's no need to. But let's just do it for the sake of doing it. Leave that x alone. And what I could do is I could take the power of 2 up, so I could write that as negative a third natural logarithm of 3x add 2 squared plus a third natural logarithm of 3x take away 2 plus c. Because I've got a third in both of these, I could just write that as, I'm going to write that as a third. This thing here would be ln 3x take away 2 take away ln 3x add 2 squared plus c, and then I could combine those lns. Now there's absolutely no need to have done this, but just to show you algebraic manipulation with logarithms, 3x over 2 over 3x add 2 all squared, and I can make that a modulus plus c, like that. But you could have left your answer like that and there was no need to go this far. And the last one we're going to do, example 5. We've got a quadratic on top and a cubic on bottom. So I could also, if you think about it, if I factorised the bottom, it would be written in this form. It would be 6 add 3x take away x squared divided by x squared x add 2. So that's a repeated root. So this would be in the form some number over this factor, which I'll put as x for 2, plus some number over this factor, which is x, plus some number over that factor repeated, which would be x squared. And that would be the 6 add 3x take away x squared all over x cubed plus 2x squared. So my next line of working would be that 6 add 3x take away x squared would therefore be equal to ax squared plus bx x add 2 plus cx add 2, like that. And I could find my a, b and c in the usual way. Now how would I do this? The first thing I'd probably do is let x equal 0, then this thing here would be 6, that would disappear, and I'd get 2c, so that would tell me that c is equal to 3. Then what I do is I'd let x equal negative 2. If I let x equal negative 2, let's write this out in the calculator. 6 add 3x take away x squared, like that, and I press calculate and I let x be negative 2, I get negative 4. So I get negative 4 is the same thing as that would disappear, and negative 2 all squared would be 4, so I get 4a, and that would tell me that a is therefore equal to negative 1. And lastly, I put something in there to find another value. I put something like x is equal to 1, let's say. If x is equal to 1, calculate when x is 1. This whole thing would be 8. So I'd get myself that a is the same thing as, that would just be a. So a, this thing here would be 1 times, this thing here would be 1 times 3, which would be 3, so it would be plus 3b. And this thing here would be plus 3c. Now I know a and c, so a would be equal to negative 1 plus 3b plus 9. So 8 would therefore be equal to 8 plus 3b, and subtracting 8 off both sides, you get therefore that b would be equal to 0 in that case. So I could rewrite this whole thing, therefore. I could rewrite this integral here that I'm trying to find, that integral, I could rewrite it as the integral. Now a over x plus 2, so a was negative 1, so negative 1 over x plus 2. Plus b over x, b was 0, so no x's, plus c over x squared, and c was 3, so plus 3 over x squared with respect to x. So I could break that up into negative the integral of 1 over x add 2 with respect to x, plus 3 the integral of 1 over x squared with respect to x. This thing here is a log, so that would be negative natural logarithm of x add 2. This thing here is basically the integral of x to the negative 2, add 1 to the power and divide, so that would be subtract 3x to the negative 1 plus c. And I could rewrite that as negative natural logarithm of x add 2, subtract 3 over x plus constant c, and we're done. That's all the integration that we need to do involving partial fractions. As you can see, it's quite involved, the algebra is quite heavy, so you have to practice a lot. As such, I'd suggest you do the following exercise in the book to make sure you have all the practice you need. Thanks loads for watching.